Our Tennessee State Standard for today comes out of the number system. It's 8NSA1. Know that numbers that are not rational are called irrational. Understand informally that every number has a decimal expansion. For rational numbers, show that the decimal expansion repeats eventually and convert a decimal expansion, which repeats eventually, into a rational number. Our lesson objective today, I am learning to change fractions into decimal numbers, so you'll need to stop and write that down. Now, I did not include the picture of the number system on your notes, but it is on your very first set of notes. And just remember, we have talked about the natural numbers being the numbers we can count on our fingers, the whole numbers being the natural numbers and zero, the integers being the natural numbers, 0, and all the opposites of the natural numbers, which would be negative numbers. And today we're going to look at rational numbers. Rational numbers can be fractions or decimals. So I want you to think about this and be prepared to talk with your partner when you come back to class tomorrow. Which type of rational number do you see most often, fractions or decimals? Which do you prefer to use and why? And I'm going to let you talk about that with your partner across from you tomorrow. Then I want you also to think, how would you write 1/4 as a decimal? And I want you to go ahead and have that on your notes when you come in. And how would you write 1/3 as a decimal? Have that on your notes as well. And then what difference do you see in these two decimal numbers? You are going to be discussing that difference, so you definitely want to have that on your notes when you come in. All right, rational numbers are numbers that can be written as fractions. They include integers, fractions, repeating, and terminating decimals. A terminating decimal is a decimal number that ends because the division ends with a remainder of 0. And some examples are negative 0.85 and 3.257. Now, really the way to say that would be negative 85 1/100ths. Then you have 3 and 257 thousandths. All right, a repeating decimal has a pattern that repeats itself without end. We have negative 1.333, and then you see this ... This just means that that number, that pattern keeps going, and you will see that quite often. Another way that you can see that will be 2.5 with a bar over the 5. That bar notation means that 5 keeps repeating. And your definition, bar notation, is used to indicate that a digit or a group of digits repeats. All right, if we want to write a fraction as a decimal, 5/8 is the fraction, and that means 5 divided by 8. So the number that's on the bottom goes on the outside of the division, and the number on top is what's being divided, so it goes inside. Now, I always tell my students, carry that decimal point up. Go ahead and put that in. And I also tell them to cover every digit except that first one. So look at this, 8 goes into 5 how many times? Well, 8 won't go into 5 because 5 is smaller. So now you can look at 8 goes into 50 times, or 50 6 times. Then you say 6 times 8 is 48. You subtract that, so that would be 50 minus 48 is 2, and you bring down the next number. Then 8 goes into 20 2 times. 2 times 8 is 16. If you subtract 16 from 20, you get 4. Bring down that next digit, and 8 goes into 40 5 times. 5 times 8 is 40. And if you subtract, you end up with a 0. That means this is a terminating decimal. It ends with a remainder of 0. So 5/8 equals 625 thousandths. So you may need to stop the video to write that down. Now, you also might have a mixed number. 1 2/3 means 5/3. And the way you get that, 3 times 1, the denominator, times the whole number. And then you add the numerator to that. So 3 plus 2 equals 5. And then you divide by the denominator. So that would be 5/3, which means 5 divided by 3. The bottom number, the denominator, goes on the outside, and the number being divided, that's the numerator, goes on the inside. So 3 goes into, well, let's put our decimal first. 3 goes into 5 one time. 1 times 3 is 3. When we subtract that, we get 2. Bring down the next digit. 3 goes into 26 times. 6 times 3 is 18. If we subtract 18 from 20, we get 2. Bring down the next digit. 3 goes into 20. Well, we already know that. Do you see a pattern here? 6 times 3 is 18. When we subtract, I don't think we need to move on any further because we can see that the 6 is going to repeat. So we can show 5/3 as 1.6 with a bar over it, or 1.6666 repeating. The pattern repeats. And remember, bar notation is used to indicate that a digit or a group of digits repeats. So make sure you have that down. So here are your turns. I want you to work on those. I want you to show your work. Use long division just like we did in the examples. And we will work on those tomorrow in class. Baseball. In a recent season, St. Louis Cardinals first baseman Albert P., because I don't know how to pronounce that, had 175 hits in 530 at-bats. To the nearest thousandth, find his batting average. So thousandth is going to be the third decimal place. And I just want you to think about what is being divided, what number goes on the top as the numerator, and what number goes on the bottom as the denominator. We will work on that in class tomorrow. In Mrs. Townley's 8th grade science class, 4 of 22 students did not turn in their homework. Oh, I hope that doesn't happen to us because we'll have working lunch. To the nearest thousandth, remember that's 3 decimal places, find the decimal number of students that did not turn in their work. So you need to think about which number is on top, the numerator, and which of those numbers is on the bottom as the denominator. And that concludes our lesson. We'll look at those problems tomorrow.